This video is about questions and answers on hyperbolic functions. If y is equal to tan inverse of hyperbolic sine of x, show that the y dx is equal to cos y. So the function we're given is y is equal to tan inverse of hyperbolic sine of x. So now, if y is equal to tan inverse of hyperbolic sine of x, then it implies that tan y is equal to hyperbolic sine of x. So now we need to differentiate tan y and we need to differentiate hyperbolic sine of x. But then let's differentiate hyperbolic sine of x over here. So now let's let a to be equal to sine x. So dA is equal to, if you differentiate sine x, you are going to get cos x. So now we are going to then put that here. So tan y, if you differentiate tan y, you first differentiate y, which is y prime. Then if you differentiate tan y, you are going to get sec squared. So sec squared y equals cos x. So let's make y prime the subject. So y prime is equal to cos x divided by sec squared y. But then we know that there is an identity for cos x, because we know that cos squared x minus hyperbolic sine squared x is equal to 1. So this implies that cos x is equal to square root of 1 plus hyperbolic sine squared x. So we are going to replace all of this by square root of hyperbolic sine squared x. So y prime is equal to square root of 1 plus hyperbolic sine squared x divided by sec squared y. But then remember that we said tan y is equal to hyperbolic sine x. So hyperbolic sine squared x is tan squared y. So this implies that tan squared y is equal to hyperbolic sine squared x. So y prime then becomes, y prime is equal to, the square root of this will become square root of 1 plus hyperbolic tan squared y, not hyperbolic. So tan squared y divided by sec squared y. But from trig identities, we know that 1 plus tan squared y is equal to sec squared y. So y prime is equal to, and so square root of 1 plus tan squared y is going to be sec y. So here is going to be sec y divided by sec squared y. So y prime is equal to, this sec y will cancel one of the sec y at the denominator. So we'll be left with 1 divided by sec y. And 1 divided by sec y is equal to cos y. Therefore, y prime is equal to cos y. And that is exactly what we were asked to show from the proof. So we are supposed to differentiate the following functions. A, g of x equals x sine inverse of x squared. So let's start with A. So the A part is g of x is equal to x hyperbolic sine inverse of x squared. Now let's let A to be equal to hyperbolic sine inverse of x squared. This implies that sine A, hyperbolic sine A, is equal to x squared. So A prime, then if you differentiate hyperbolic sine A, you get hyperbolic cos A equals, if you differentiate x squared, you get 2x. So a prime is equal to 2x divided by cos a. But then we know that from trig identities, cos a is the same as square root of 1 plus hyperbolic sine squared a. So a prime becomes 2x divided by square root of 1 plus hyperbolic sine squared a. But then remember we said that sine a is equal to x squared. So hyperbolic sine squared a becomes x squared all squared, which becomes x exponent 4. And therefore a prime is equal to 2x divided by square root of 1 plus x exponent 4. So now we have found the derivative of sine inverse of x squared. So we can then use product rule to find g prime of x. So in this case, g prime of x is equal to differentiate x and keep sine inverse of x squared constant. So if you differentiate x, it becomes 1. So here will become 1 times hyperbolic sine inverse of x squared, then plus, then you keep x constant, so x, then you differentiate hyperbolic sine inverse of x squared, and that is what we did for a prime. So a prime is 2x over square root of 1 plus x exponent 4. So here's x 2x, so times 2x divided by square root of 1 plus x exponent 4. So g prime of x is equal to sine inverse, hyperbolic sine inverse of x squared, then plus, here becomes 2x squared divided by square root of 1 plus x exponent 4. So if we find the LCM, then we find out that g prime of x is equal to square root of 1 plus x exponent 4 hyperbolic sine inverse of x squared, then plus 2x squared, all divided by square root of 1 plus x exponent 4. So the B part says that h of x equals, into bracket, cos x exponent x. So we are supposed to find h prime of x. So let's let a to be equal to, into bracket, cos x exponent x. So let's take natural log of both sides. So natural log of a is equal to x natural log of, into bracket, cos x. So now if you differentiate len a, it's going to be a prime divided by a, and this is equal to, we can use product rule here. So you keep x constant and then you differentiate len cos x. So x, now if you want to differentiate len cos x, you first differentiate what is inside the bracket. If you differentiate cos x, cos s, you get sin x divided by cos x. Now I have already made a video on the derivatives of logarithmic functions. I will link it into the, I'll put the video in the description so you can watch that video. Then plus, you keep len cos x constant, you differentiate x. If you differentiate x, is 1. So here becomes 1 times len, into bracket, cos x. So a prime is equal to, now sin x over cos x is tan x, so it becomes x hyperbolic tan x, then plus natural log of cos x. So now, this is divided by a. So but a is the same as cos x exponent x. So a prime is equal to, into bracket, cos x exponent x, then times x tan x plus natural log of cos x, bracket close. But we said that a is what? Cos x exponent x. So, and cos x exponent x is what? H. So h of x prime is equal to cos, into bracket, cos x exponent x times x hyperbolic tan x plus ln cos x, bracket close. If y is equal to cos, into bracket, sine inverse of x, show that, into bracket, 1 minus x squared d squared y dx squared minus x dy dx minus y is equal to 0. So this looks like a differential equation. However, this is y. Y is equal to cos, into bracket, sine inverse of x. So the first thing is to find y prime. But before we can find y prime, let's let a to be equal to sine inverse of x. So this implies that sine a is equal to x. Now if you differentiate sine a, it is a prime. And then if you differentiate sine a, you get cos a, because if you differentiate x, it is 1. So a prime is equal to 1 divided by cos a. But then we know that cos squared a plus sine squared a from trig identities is equal to 1. And therefore cos a is equal to square root of 1 minus sine squared a. So this means that this a prime is now equal to 1 divided by square root of 1 minus sine squared a. However, we said that sine a is equal to x. So sine squared a is going to be x squared. And therefore, a prime is equal to 1 divided by square root of 1 minus x squared. So if you differentiate sine inverse of x, you are going to get 1 divided by square root of 1 minus x squared. So now we can find y prime from here. So we know that y is equal to cos, into bracket, sine inverse of x. So y prime is equal to, you first differentiate what is in the bracket. And if you differentiate sine inverse of x, you are going to get this value, which is, now this can also be written as, into bracket, 1 minus x squared exponent minus 1 over 2. So I'll rather write it like this. So this is equal to bracket 1 minus x squared exponent minus 1 over 2. Then you differentiate the whole function. If you differentiate cos x is going to be shin. So here we're going to give us hyperbolic sine. So shin, into bracket, sine inverse of x. Now here's d squared y dx squared. So that is the second derivative. So we need to find y prime prime. So in finding y prime prime, we need to differentiate y prime. So you keep this one constant and you differentiate sine inverse of x. So this is going to give us 1 minus x squared exponent minus half. And then if you differentiate sine inverse of x, we are going to get times 1 minus x squared exponent minus half. And then if you differentiate hyperbolic sine, you get the hyperbolic cos. So cos sine inverse of x. And then you keep sine inverse of sine x constant, and you differentiate this function. So now I want to continue from here. So plus, there's a plus here, but I want to write this term down here. So now if you differentiate this, minus half will come down. Then you multiply by, if you differentiate what is in the bracket, you differentiate minus 2x x squared, you are going to get times minus 2x. And then all of this is going to multiply. Now 1 minus x squared exponent minus half minus 1 will give us exponent minus 3 over 2. And then you repeat this function, which is hyperbolic sine of x into bracket sine inverse of x bracket close. So now, in putting y prime prime into perspective, you will see that this 1a exponent minus half times a exponent minus half is going to give us a exponent minus half, which is the same as a exponent minus 1. And therefore, y prime prime is going to be equal to, into bracket, 1 minus x squared into bracket exponent minus 1, then times cos sine inverse of x. This was the function we began with. Cos sine inverse of x is the same as y. So I want to write here y. Then if you multiply these two, it's going to give us plus. Now, so minus half times minus 2x is going to give us plus x, then times 1 minus x squared exponent minus 3 over 2, then hyperbolic sine of sine inverse of x bracket close. So now, having found y prime and then y prime prime, we can then put them into this equation and continue. So we got y prime as, into bracket, 1 minus x squared exponent minus half hyperbolic sine of sine inverse of x, and then y prime prime as, into bracket, 1 minus x squared exponent minus 1y plus x times 1 minus x squared exponent minus 3 over 2 hyperbolic sine of sine inverse of x. But this is the equation that we are supposed to prove. So now, the equation is saying that we should multiply 1 minus x squared by y prime prime. That is the second derivative. So 1 minus x squared times d squared y dx squared is equal to, now wherever we see, we multiply by this term. So if we multiply 1 minus x squared, here's 1 minus x squared. So here's exponent minus 1, and here's exponent 1. So that will cancel out to give us 0. So it's going to be like this: 1 minus x squared exponent 1, then times 1 minus x squared exponent minus 1, then times y, then plus into bracket 1 minus x squared times, so there is already an x here, so let me bring the x out, times 1 minus x squared exponent minus 3 over 2. Then here's hyperbolic sine of sine inverse of x. So now, if we simplify further, we are going to get this term times this term is going to give us 0. So here we'll be left with y, then plus x. However, this term is 1 minus x squared, then 1 minus x squared. Here's exponent minus 3 over 2. So at the end of the day, it's going to be minus 3 over 2 plus 1, which is the same as minus 1 over 2. So this is going to give us times 1 minus x squared exponent minus 1/2 hyperbolic sine of sine inverse of x. So we've been able to solve this term. Now it's left with this term, which is x dy dx. So that means you are going to multiply y prime, which is this term, by x. So if you multiply this by x, it's going to give us x, then 1 minus x squared exponent minus 1/2 hyperbolic sine of sine inverse of x. So now we can then put it into this equation. So it is this one, 1 minus x squared d squared y dx squared, which is all of this term. So that is going to give us y plus x times 1 minus x squared exponent minus 1/2 hyperbolic sine of sine inverse of x, then minus x dy dx, so minus this term, so minus x into bracket 1 minus x squared minus half sine of hyperbolic sine of sine inverse of x, then minus y, so minus y. However, you can see that this minus y and minus y plus y will cancel out. So we are going to be left with x into bracket 1 minus x squared exponent minus half hyperbolic sine of sine inverse of x, then minus x times 1 minus x squared exponent minus half hyperbolic sine of sine inverse of x. So you see that it is the same term that are subtracting. So this is going to give us 0. So this is equal to 0. And that is exactly what the differential equation was asking us to prove. Now show that the function f and g defined by f of x equals hyperbolic sine inverse of tan x and g of x equals hyperbolic tan inverse of sine x have equal derivatives. So we are supposed to show that f prime of x is equal to g prime of x. So let's first find f prime of x. However, from the question, f of x is equal to hyperbolic sine inverse of tan x. So let's find f prime of x. So this implies that hyperbolic sine of f of x is equal to tan x. So now let's differentiate. To differentiate hyperbolic sine of f of x, we need to first differentiate f of x, which will give us f prime of x. And if you differentiate hyperbolic sine, you get hyperbolic cos. So this becomes hyperbolic cos of f of x. And this is equal to, if you differentiate tan x, you are going to get sec squared x. So now this implies that f prime of x is equal to sec squared x divided by cos into bracket f of x. So let's continue from here. So f prime of x is equal to sec squared x divided by cos into bracket f of x. However, from trig identities, we have already established that cos a is equal to square root of 1 plus hyperbolic sine squared of a. So we are going to replace all of this. So f prime of x is equal to sec squared x divided by square root of 1 plus hyperbolic sine squared of f of x. Let me use the big brackets. However, we said that hyperbolic sine of f of x is equal to tan x. So we can replace this hyperbolic sine squared of f of x by tan squared x. So f prime of x is equal to sec squared x divided by square root of 1 plus tan squared x. But we know from trig identities that 1 plus tan squared x is equal to sec squared x. So f prime of x is equal to sec squared x divided by sec x, and therefore f prime of x is equal to sec x. So we have been able to find f prime of x. Let's find g prime of x. If we are also able to get g prime of x equal to sec x, then we know that the two functions have equal derivatives. We said that g of x is equal to tan inverse of x, and we're able to show that f prime of x is equal to sec x. So let's find g prime of x. So if g of x is equal to hyperbolic tan inverse of sine x, it implies that hyperbolic tan g of x is equal to sine x. So let's differentiate this. So if you differentiate hyperbolic tan of g of x, you first differentiate g of x to get g prime of x, and you differentiate hyperbolic tan. And if you differentiate hyperbolic tan, you are going to get the hyperbolic sec of g of sec squared of g of x. And if you differentiate sine x, you get cos x. So g prime of x is equal to cos x divided by hyperbolic sec squared g of x. Hyperbolic sec squared a is equal to 1 minus hyperbolic tan squared a. So let's notice the difference, and therefore g prime of x is equal to cos x divided by 1 minus hyperbolic tan squared g of x. But we said that hyperbolic tan of g of x is equal to sine of x. So 1 minus hyperbolic tan squared g of x is going to give g prime of x as cos x divided by 1 minus sine squared x. And then 1 minus sine squared x is cos squared x from trig identities, because cos squared x plus sine squared x is equal to 1. So g prime of x is equal to cos x divided by cos squared x, and this is equal to 1 over cos x. But we know that 1 over cos x is equal to sec x, and therefore g prime of x is equal to sec x. But we got f prime of x to also be equal to sec x, and for that reason, since g prime of x is equal to sec x and f prime of x is equal to sec x, it implies that their derivatives are equal. That is, g prime of x is equal to f prime of x. To solve the equation, len x equals 2 sine inverse of 3 over 4. Now, what is sine inverse of x? It is giving us the natural log of x plus into brackets x squared plus 1. Now, this I have proved in a previous video about the derivatives of hyperbolic functions, so you can go back and watch that video. So now, this implies that sine inverse of 3 over 4 is going to be equal to natural log of x is now 3 over 4 and plus square root of 3 over 4 squared and plus 1. So therefore, ln x is equal to natural log of into bracket 3 over 4 then plus square root of 3 squared is 9, then 4 squared is 16 plus 1. So ln x is equal to natural log of 3 over 4 then plus square root of, now 16 times 1 is 16 plus 9 is 25, so it's going to give us square root of 25 over 16. And therefore this is natural log of x is equal to natural log of 3 over 4 and plus square root of 25 is 5 and square root of 16 is 4. So let me continue from here. Natural log of x is equal to natural log of 3 over 4 plus 5 over 4 is 8 over 4. So natural log of x is equal to 8 over 4 is the same as natural log of 2. So therefore, sorry, I made a mistake. It is 2 sine inverse of 3 over 4. And therefore, natural log of x, there's supposed to be a 2 here. So therefore, there's supposed to be a 2 here. So natural log of x is equal to natural log of 2 squared. So natural log of x is equal to natural log of 4. And therefore, this implies that x is equal to 4. So prove that hyperbolic sine x minus x and x minus hyperbolic tan x are increasing function for all x. That is for x greater than 0. And also deduce that hyperbolic tan x is less than x, which is less than sine x, which is less than cos x. So now, let's let f of x to be equal to hyperbolic sine x minus x. Let's find f prime of x. F prime of x is, if you differentiate hyperbolic sine x, you will get hyperbolic cos x, minus, if you differentiate x, you will get 1. Now, the range, if you remember the graph of cos x, the graph of cos x looks like this. This is 1. So the graph of cos x has a range of 1 and then infinity. So it means that for x greater than 0, then it implies that cos x is always going to be greater than 0. And therefore, cos x minus 1 is always going to be greater than 0. And therefore, f prime of x is greater than 0. So now, if f prime of x is greater than 0, it means that this function, f of x, is an increasing function. It's an increasing function. If you don't understand the principle behind this, I made a previous video about increasing and decreasing functions, so you can watch it and then you understand why it is so. If f of x is an increasing function, it implies that f of x is greater than f of 0. So what is f of x? F of x is hyperbolic sine x minus x. So that is greater than f of 0 is the same as hyperbolic sine 0 minus x is 0. Now sine 0 is 0 minus 0, it will give you 0. So therefore, hyperbolic sine x minus x is greater than 0. And this implies that x is less than hyperbolic sine x. Now let's come to this one, which is x minus hyperbolic tan x. So let's let g of x to be equal to x minus hyperbolic tan x. So g prime of x is equal to 1 minus, if we differentiate hyperbolic tan x, we are going to get hyperbolic sec squared x. But we know that from hyperbolic identities, 1 minus sec squared x is equal to hyperbolic tan squared x. So g prime of x is equal to hyperbolic tan squared x. Now, hyperbolic tan squared x, if you remember the graph, it is a function which is always increasing. This is how the graph looks like. There are horizontal asymptotes 1 and then -1, and then the graph looks like this. So this is how the graph of tan x looks like. So hyperbolic tan squared x is going to always throw out a positive number, and therefore g prime of x is greater than 0. So since g prime of x is greater than 0, then it implies that g of x is an increasing function. So this is an increasing function. Now, if g of x is an increasing function, then it also implies that g of x is greater than g of 0. So now, we know that g of x is equal to x minus tan x. So it implies that x minus tan x, hyperbolic tan x, is greater than g of 0, which is 0 minus hyperbolic tan of 0. Now, if we check this graph, at x equals 0, tan 0 is 0. Therefore, all of this will tend to 0. So x minus tan x, hyperbolic tan x, is greater than 0. This implies that x is greater than hyperbolic tan x. So now, in one breadth of our proof, we see that x is less than hyperbolic sine x, and then x is greater than hyperbolic tan x. So it means that x is greater than hyperbolic tan x, but x is less than hyperbolic sine x. And so we have proved all of these parts. Now we need to then compare hyperbolic sine x and hyperbolic cos x and see which one is greater. So from the question, we are supposed to prove that x is greater than tan x, or in other words, hyperbolic tan x is less than x, which is less than hyperbolic sine x, which is less than cos x. But we have been able to prove this part, which is tan x less than x less than hyperbolic sine x. So we need to then compare sine x and cos x and see if sine x is less than cos x, then our proof is true. So now let's let capital H of x to be equal to hyperbolic sine x minus hyperbolic cos x. However, let's use their definitions. So now h of x is equal to, by definition, hyperbolic sine x is half of exponent x minus exponent minus x, then minus, so let me use curly bracket, half of into bracket exponent x plus exponent minus x. So if you do this subtraction, h of x is equal to, now this is exponent x minus exponent x, is going to give us 0, and then exponent minus exponent x minus x minus exponent minus x is going to give us, but there is half here, so it's going to be there with minus half exponent minus x, then minus half exponent minus x, and this is equal to minus exponent minus x. Now for x greater than 0, exponent minus x would always be greater than 0. So minus exponent minus x is going to be less than 0. And therefore, h of x is less than 0. So this implies that hyperbolic sine x minus hyperbolic cos x is less than 0. And therefore, this is hyperbolic sine. So hyperbolic sine x is less than hyperbolic cos x. And therefore, at the end of the day, our proof is true that tan x is less than x, which is less than hyperbolic sine x, which is less than hyperbolic cos x. Find the derivative of y equals exponent cos 3x. So what we need to do is to take natural log of both sides. So natural log of y is equal to natural log of exponent cos 3x. So now we need to find this derivative. So if you want to find the derivative of ln y, it is y prime divided by y equals. Now this will come down to give us, okay, let me not do the derivative here. So natural log of y is equal to hyperbolic cos of 3x, then natural log of e. Now ln e is 1, therefore natural log of y is equal to cos 3x. So now, in taking the derivative, if you differentiate ln y, is y prime over y equals, if you differentiate cos 3x, you first differentiate 3x, which you will get 3. Then you differentiate cos 3x, which you are going to get sin 3x. So this implies that y prime is equal to 3y sin 3x. But we know y. Y is exponent cos 3x. And therefore, y prime is equal to 3 sin 3x exponent cos 3x. Prove that tan ln x is equal to x squared minus 1 divided by x squared plus 1. So we know that by definition, hyperbolic tan a is equal to exponent 2a minus 1 divided by exponent 2a plus 1. So hyperbolic tan ln x is equal to exponent 2 ln x minus 1 divided by exponent 2 ln x plus 1. So this can also be written as exponent ln x squared minus 1 divided by exponent ln x squared plus 1. Now exponent ln x is 1, so this is equal to x squared minus 1 divided by x squared plus 1. If hyperbolic tan x is equal to 12 over 13, find exponent x and exponent minus x. So we know that hyperbolic tan x is equal to a hyperbolic sine x divided by hyperbolic cos x, and that is equal to 12 over 13. So it implies that hyperbolic sine x is equal to 12, and then hyperbolic cos x is equal to 13. But by definition, we know that hyperbolic sine x is half of exponent x minus exponent minus x, and that is equal to 12. So it implies that exponent x minus exponent minus x is equal to 12 times 2 is 24. So this is equation 1. And then by definition, we know that hyperbolic cos x is half of exponent x plus exponent minus x. That is equal to 13. So this implies that exponent x plus exponent minus x is equal to 26. And this is equation 2. So let me rewrite both equations here. So we have exponent x minus exponent minus x equals 24. And then exponent x plus exponent minus x equals 26. So now let's add, this is equation 1 and this is equation 2. So let's add equation 1 and equation 2. So exponent minus x will go to 0. So that we will then have 2 exponent x equals 24 plus 26. Therefore, 2 exponent x is equal to 24 plus 26 is 50. Therefore, exponent x is equal to 25. And then let's subtract equation 1 from equation 2. So it becomes exponent minus x minus exponent minus x equals 26 minus 24. So 2 exponent minus x is equal to 26 minus 24 is 2. So exponent minus x is equal to 1. So therefore, exponent x is equal to 25, and then exponent minus x is equal to 1.